This video shares early results from a collaboration between Simpol and Smartsettle. Together, we explore what a truly global climate agreement could look like, one where countries don't act alone, but move together. We're not here to promote a specific policy outcome. Instead, we're demonstrating a different process, an alternative to decades of UN climate talks, known as COP, that have struggled to produce binding, coordinated action. In the 1950s, only a handful of scientists believed humans were warming the planet. Emissions were low. By the early 1990s, scientific consensus had grown enough to launch COP. Today, consensus is nearly unanimous, yet global emissions have risen almost tenfold. The climate challenge is no longer mainly scientific. It's political, economic, and institutional. The real problem is how to coordinate action across nations. So why has COP struggled? The core issue is structural. We're stuck in what's called a multipolar trap. Every country acts in what it sees as its own interest, unsure whether others will follow through. As a result, cooperation breaks down. Targets are announced, but real, enforceable coordination rarely follows. The problem isn't a lack of knowledge or goodwill. It's the absence of a decision structure that aligns incentives and accountability. Simpol addresses this by focusing on simultaneous implementation. When everyone moves together, no one is punished for acting first. Smartsettle Infinity makes this practical. It provides a secure, neutral space where countries can negotiate multiple issues at once, model preferences, and see fair, optimized outcomes before committing. This shifts the conversation from vague promises to concrete, synchronized policies. For global agreements to hold, they must serve both the common good and national self-interest. When that happens, verification and enforcement become rational choices, not burdens. But structure alone isn't enough. Political will matters. Simpol helps build that will by enabling voters across countries to support politicians who commit to coordinated global action. This gives civil society something it's long lacked, a practical way to counter vested interests and push governments toward real cooperation. To keep this simulation manageable, we grouped the UN's 16 climate negotiating blocs into 6 representative stakeholder groups. This preserves the main geopolitical and economic differences while keeping the model workable. To explain the core idea, let's first simplify even further. Imagine 2 broad camps, developed nations and developing nations. At COP, issues are often negotiated one at a time, as zero-sum battles. One side's gain is seen as the other's loss. This almost guarantees stalemate. In game theory, this deadlock is called a Nash equilibrium, a situation where no one moves because moving alone seems risky, even though everyone would benefit if all moved together. With climate change, this isn't just inefficient, it's dangerous. John Nash also showed that escape is possible. Instead of win-lose bargaining, integrative negotiation focuses on maximizing joint gains across many issues at once. Even in a simple 2-dimensional picture, we can see how cooperation opens up far better outcomes for everyone. When we map each party's preferences, another boundary appears, the efficiency frontier. Every point on it represents an outcome where no one can gain without someone else losing. Together with the status quo, this defines the zone of possible agreement, real value waiting to be unlocked through transformative collaboration. Using conservative assumptions, our simulation shows this zone represents a potential gain on the order of $1 trillion per year over the status quo. The question isn't whether this value exists, it's how to harvest it. Smartsettle builds on decades of research, starting with the Maximize the Minimum Gain algorithm developed at Cornell by Ernest Thiessen. Harvard professor Howard Raifa's endorsement of Thiessen's work, over that of John Nash in this specific context, helped motivate turning this theory into practice. His team soon realized that the original algorithm was not enough, and over the years, it has grown into a multi-stage decision architecture designed to address the specific failure modes of complex multi-party negotiations and convert adversaries into collaborators. Visual blind bidding lets parties express preferences without strategic posturing and virtually eliminates the tedious negotiation dance that characterizes traditional methods, and the single negotiating framework captures all issues and trade-offs in one shared structure that enables integrative optimization. Together, these replace positional bargaining with transparent, interest-based collaboration. The single negotiating framework functions as an evolving draft treaty, recording areas of agreement while clearly isolating what still needs to be resolved. Human mediators guide the process. AI supports it, revealing options, consequences, and trade-offs. Judgment remains human. The system simply helps people see what's possible. In our simulation, the framework includes emissions targets, technology sharing, verification, and funding mechanisms. Crucially, issues are defined as ranges or options, not fixed demands. This is what makes optimization possible. Once a problem is well defined in this way, with issues, options, constraints, and incentives made explicit, true optimization becomes possible. Parties then negotiate privately through a secure neutral site. In our recorded simulation, we will be following the G7, showing you how they specify their confidential preferences and prepare for exchange of proposals, concessions, and system-generated suggestions that gradually converge. When all parties independently accept the same package, an agreement is reached. Let's now back up a step and see how this looks in the Smartsettle Infinity interface from the G7's private perspective, where they model their own preferences and prepare for bargaining. Private preferences are kept confidential by the system. The negotiating range on each issue here is oriented so that the options most preferred by the G7 are on the right-hand side. The G7 have organized the issues so that those that contribute to package ratings in purple are near the top of the screen. Towards the bottom are the individual emission reduction targets of the other country groups and various climate fund contributions or withdrawals. The G7 is not directly concerned with these individual outcomes, but rather with their cumulative effect and their own obligations as represented by the purple-colored issues. One example is the G7's required commitment to the Global Climate Fund. On this issue, the G7 prefers low values. The G7 has assigned 300 important points to this issue. These points reflect how valuable this issue is to the G7 alone. We also see this when we open the satisfaction graph. Since the graph here is linear and the range is $300 billion per year, we can easily calculate that one importance point represents $1 billion per year. This establishes the importance scale for all the other issues. At the top of the panel are the issues related to emissions reduction. When we open the satisfaction graph for G7 emissions reduction, we see that the satisfaction graph is concave. This means that it becomes increasingly more difficult to reduce emissions with higher commitments. The entire negotiating range for this issue is assigned 65 points. This corresponds to an estimated cost of $65 billion per year to reduce emissions from the current rate of 0.5 to 3.6 gigatons of CO2 emissions per year. The next two issues aggregate the emission reduction commitments of all nations. The first is in gigatons, and next is the corresponding percentage. Only one of these needs a satisfaction graph. When we inspect that graph, we see that the G7 expects to benefit from global emissions reduction to the tune of $300 billion per year over the entire given range. One of the optioned issues is how to account for carbon removal. G7 considers Integrity Council for the voluntary carbon market as equivalent to the status quo and sets the bar for this option to 0. 3 of the other options are worse than the status quo with negative ratings, and only one, MRV for carbon removal, is preferred, set at a value of 10. The whole issue is worth 75 points, which is the difference between the best and the worst option. On the right side is where the G7 keep track of alternative outcomes. There is nothing yet on the table for all parties to see. The G7 have created 5 private reference packages to help them understand their own preferences, and also for use in the bargaining phase about to begin. The ratings of these packages are determined by the individual ratings assigned to the values that make up the package. Among these reference packages, the one least preferred to the G7, worth 0 points, is named status quo. Any outcome worth 0 or less would be totally unacceptable. However, the G7 actually walks away from the table before accepting anything worse than their walkaway package, worth 80 points. Their goal is an outcome worth at least 108 points. While the package named Target would be quite acceptable to the G7, they decide to start by proposing an optimistic package. When they do so, the initial proposals of the other parties also appear on the table. Among those proposals, the one submitted by the small island developing nations, worth 110 points, looks quite good, even better than their target, so the G7 decide to accept this package. Having experienced in simulations Infinity's ability to generate interesting packages, the G7 request a suggestion to be generated. Several suggestions appear, and the G7 accepts some of them after inspecting each one carefully. Each time they accept a package, a secret yellow dot appears. Other parties do not know which packages the G7 have accepted. At this point, the G7 decides to end Session 1. Smartsettle will declare an agreement if at the end of a session all parties have accepted the same package. Unfortunately, no agreement is reached in Session 1. In Session 2, the G7 put their planned concession on the table. Some of the other stakeholder groups also offer visible concessions. One of these, from emerging high emitters, is above the G7's walkaway level, but the G7 are not ready to accept that package. Instead, they decide to put their target package on the table, but they do so strategically in stealth mode, submitting the package anonymously as a masquerade. In this way, the target package is disguised as a typical suggestion. This technique helps bypass bias that might otherwise block agreement. At the close of Session 2, no agreement is reached. In Session 3, the G7 try a special technique called equivalent suggestion that sometimes helps to solve an impasse. Smartsettle tries extra hard to generate a suggestion that achieves the satisfaction levels that all parties have already indicated they need to reach. When doing so, Package 26 appears, which happens to be rated the same as Package 24, which the G7 have already accepted. Logically, if their preferences are well represented, the G7 should be willing to accept Package 26. And when they do so and end Session 3, they are thrilled when they see the green dot appear. Package 26 is declared as a baseline agreement, meeting their target aspirations. The excitement is palpable, but with their training on Infinity's ability to uncover hidden value, an improvement is also requested. Smartsettle generates Package 27, which becomes the final agreement after all parties confirm that it is even better than the baseline. This moment highlights the transformative power of the Smartsettle Infinity process, uniting parties and achieving surprising outcomes beyond their expectations. The improvement is worth 58 points more to the G7 than the baseline agreement. In this run, the agreement represents sustained global emissions reductions of about 12% per year, a trajectory consistent with pathways that sharply reduce the probability of the most severe climate outcomes. Across all stakeholders, the combined gain relative to the status quo approaches $1 trillion annually. The improvement over the baseline shown here for each party are not predictions. These actual simulated numbers from the interface are simply meant to demonstrate a proof concept illustrating what's possible under conservative assumptions. How the gains are distributed under the covers are governed by our core algorithm, maximize the minimum gain. After normalization, other algorithm-determined modifications, and subjection to constraints, the final distribution of gains will invariably appear not to be uniform. But parties have no reason not to accept the results as fair. The improvement over the baseline is 30% on average, which we consider remarkable, given the number of parties involved, but perhaps not surprising, given that an agreement was reached in just 3 sessions. In a real negotiation, we might expect that the parties could achieve this value, but much of it would likely be already represented in the baseline if the process took many sessions to reach that point. The key lesson here is not the specific numerical outcome we've shown, but the structured, repeatable consensus-building process that produced it, a process that can be applied far beyond climate mitigation. To emphasize that point, let's review that process. For the purposes of illustration, we're again simplifying to 2 dimensions. Imagine that a comprehensive single negotiating framework has been created, and each party's preferences are well represented, known only to the Smartsettle Infinity neutral site. The stage is set for the integrative bargaining phase of a Smartsettle negotiation. Their goal is to find an agreement better than the status quo. We represent that operative, non-cooperative equilibrium, the place that the world is presently locked into, at the origin point, labeled as the Nash equilibrium. The status quo levels, together with the efficiency frontier, define a zone of possible agreement. Within the ZOPA lies a smaller zone of likely agreement, constrained by risk tolerance, political feasibility, institutional capacity, and time pressures. This is the space where real-world agreements must actually be found. With prepared parties and a well-modeled problem, the Smartsettle process proceeds as follows. Parties start by exchanging optimistic proposals, followed by concessions. But more important are suggestions generated by a well-informed system. Some of these packages fall in the zone of likely agreement. Multivariate visual blind bidding facilitates parties quickly reaching a baseline agreement that is considered fair by all concerned. Smartsettle then applies the maximize the minimum gain algorithm, not to equalize outcomes, but to maximize the smallest relative gain among the parties, ensuring that every participant benefits as much as possible from cooperation. This process works for almost any formal negotiation that may occur between any number of parties. As more parties join, the efficiency frontier expands, from a curve to a surface to a high-dimensional space. The math is handled behind the scenes. Each participant focuses only on their own preferences. What matters most is the volume under the efficiency frontier. Our simulation estimated stakeholder-valued benefits of climate mitigation close to $1 trillion per year against costs of roughly $300 billion per year, yielding a benefit-cost ratio of more than 3 under conservative assumptions. Now consider this. The amount of money the world currently spends on peacemaking is minuscule compared to the costs of war. If even a fraction of this approach were applied to other global challenges, conflict, security, development, the potential impact would be enormous. At this point, you might reasonably ask, Smartsettle may be able to deliver coherent, optimized agreements, but how do governments get incentivized to participate and implement the results? This is where Simpol comes in. Through Simpol, citizens across countries coordinate their voting preferences around the principle of simultaneous implementation, supporting politicians and parties that commit to implementing agreed global solutions together. This creates a real political incentive. Politicians who support coordinated global action gain electoral backing. Those who do not risk losing support to those who do. In several countries, this dynamic has already led members of parliament to endorse Simpol's approach. In this way, Smartsettle provides the decision engine, while Simpol provides the political traction that makes adoption and implementation more likely. What we've shown is more than a policy prescription, it's a proof of concept. Global stalemates don't have to stay stuck. With the right structure, adversaries can become collaborators, and shared value can replace deadlock. Let's start doing this for real. Thanks for watching.